Assalamualaikum and hi to everyone. Thank you for watching this video. So basically we will continue on the topic chapter 4, which is thread. So what is thread? So thread is a basic unit of CPU utilization. Okay, as we learned on the previous video, we talked about what is thread and how it's work. Okay, so it's comprised thread ID, the program counter, a set of register, as well as the stack. So that is under the thread. In our modern computer, okay, in our computer system, the current computer system, we implement the multi-threaded. So basically, one process has a thread. Yeah, one process, traditional way, one process has a single thread. So if a process has multiple threads of control, so it can perform more than one task in a time. Okay, if we have multiple threads in one process, so that means we able to control or perform multiple tasks at one time. So then it leads to the terms that we call single-threaded process and multi-threaded process. So the motivation there is to make a computer able to process several tasks in simultaneously, or we want to utilize the capability of our computer system. So that's why we have the single thread and multi-thread. So at the previous, we already cover about the threading. So in the second part, of chapter 4, we'll focus on the multi-threading model. So what are the model that being used in order to do the multi-threading? So in multi-threading means we have one process, and in one process we have multiple thread. Okay, in our previous video, we already know and discuss about the thread, and the thread may we have a two level part of user level and also for the kernel. Okay, for user level, we use the term as user threads or by the kernel for kernel thread. So we have user thread and we also have the kernel thread. So this user thread supported above the kernel and managed without the kernel support. Okay, focus on the user part. And the kernel thread are supported and managed directly by the operating system. So basically, all the operating system has the kernel thread and the user thread, such as Windows, Linux, Mac OS X, Solaris. Those operating system support the kernel thread. Okay, so because we have the term user thread and the kernel thread, so it must have the relationship between the user thread and the kernel thread. So that's how the researcher come out with the model that we call as multi-threading model. So these are the model that establish that relationship between the kernel and the user. So the multi-threading model that we have, okay, we have three. The first one, we have many to one. Okay, we have many ones means that we have many user trait that has the relationship to one kernel trait. And then we have one to one. Okay, one to one. So in one to one model, we have user trait. One user trait create the relationship with one kernel trait. So that's why we call one to one. And the third part, we have many to many. Okay, so in many to many, we have many user trait that has the relationship with multiple kernel. So that's uh, uh, the general differentiation between type of model that we have on the multi-threading. So we have many to many, many to one, and one to one. So let's look at the many to one model. So it look like this one. So we have user trait. So we have multiple user trait, 1, 2, 3, 4 for this example, and then it has the relationship with one kernel trait. So we call as many to one. So many user level trait map to a single kernel trait here. Okay. So one trait blocking causes all to block, and multiple thread may not run in parallel on multi-core system because only one may be in the kernel at a time because we have many to one, so we cannot run it in the parallel part. And few systems currently use this kind of model. Example of the OS that use this kind of model are Solaris Green Thread and the GNU Portable Thread. So these are the many to one model. Next part, we have one to one model. So in this model, we have user thread that has the relationship with the kernel thread. So each of the user thread here map to a single kernel thread. So this part is creating a user level thread that has their own kernel thread. So creating a user level thread creates a kernel thread. When we create a user level thread, then in the same time it also create a kernel thread. So more concurrency than many to one. A number of threads per process sometimes restricted due to the overheat. So example of OS that use this kind of model one to one are Windows, Linux, and Solaris 9 and the latest Solaris 9, Solaris 10, and so on. So these are the model for one to one. So it means that the multiple thread to run in the parallel or multiprocessor. Okay, we have multiple thread and then we have multiple processor. So the drawback for this model is it's creating a user thread that require creating the corresponding kernel. Means when you have the user thread, then you need to create the kernel thread. So because of the overheat of creating the kernel thread, so, it can burden the performance of the applications. That's why we have the overheat issues. Because it will burden the performance of the application. So basically, for those applications that implement this kind of model, one to one model, it will restrict the number of threads that's supported by the system in order to overcome the issue of overhead. Okay. So the next model we have many to many. So in many to many model, okay, we have multiple user thread that map to many kernel thread. Okay, you have see here we have multiple thread. Okay, it map to multiple kernel thread. So these are the difference between one to one and one to many. So multiple it may have multiple user thread to a smaller or equal number of kernel thread. Means the kernel thread must be equal or smaller number. Okay, let's say we have user thread 4, so the kernel thread may have 4 or lower, lesser than 4. So the number of kernel thread here may be specific to either a particular application or a particular machines. So an application may be allocated more the kernel thread on a multiprocessor than on the single processor. Okay, that is for the mini to mini. So Solaris prior to version means the earlier version of Solaris use this kind of model. Okay, as well as the Windows with the thread fiber package. So there are 3 model for the trading. For the trading. Okay, another model is 2-level model. So this model is quite similar like the previous model, which refer to the M to M, many to many. Okay, the difference only it's allow a user thread to be bound to the kernel thread. So you can see this one. Okay, this one is the M to M, many to many, and this one is the 2-level mode. So the difference, we have another part that allow a user thread to be bound with the kernel thread here. Okay, an example we have IRIC has HB UX through 64 Unix, Solaris 8 and the earlier version. Okay, the previous one is Solaris 9 and the later version. This one is Solaris 8 and the earlier version of Solaris. Okay, so these are the model. We have one to one, one to many, many to many, and 2-level model. So the difference between the 2-level model and the many to many is only we have this part. Okay, it's allow a user thread to be bound with the kernel thread. So these are the difference. So the next part is about the pool, thread pool. Okay. Okay, in a thread pool, okay, the general idea for this pool, okay, for this idea of a thread pool is to create a number of threads at a process startup and place them into a pool. Mean we have one pool that in a pool we have multiple threads. So thread is being created at the process startup, and then after it's created, we will place that thread into the pool. Okay. So what the thread do? It will sit there and wait for the work. Okay, it will sit there in the pool and wait for the work. If there is any task need to be completed, so it will work. Otherwise, it just wait inside the pool. So when a server receive a request from the clients, it awaits the thread from this pool. Okay, if one is available, and it will pass it to the requested server. So that is the idea of the trade pool. Okay, how about if the pool contains no available trade when the server requests? Okay, so the server will wait until one of the trade become free, then it will entertain the request. So it's the general ideas on how the trade pools work. So what are the benefits that this kind of mechanism will offer? Yeah, the first is about the faster service, because we already have the trade. We don't need to create per request. We already create at the process startup and put inside a pool. So when there is a task, so we just call the trade. Okay, so usually slightly faster to service a request with an existing trade than create a new trade. So first is about the faster serve. Okay, second, it allow the number of trades in the applications to be bound to the size of the pool. Okay, the third one, it will separate the tasks to be performed from the mechanics of creating tasks, allow different strategies for running tasks. Okay, example here is tasks could be scheduled to run periodically. Okay, we can schedule the task. So a window API support this thread pool using this code. Okay, keywords win API, window API, pool function. So we use this pool functions about the parameter, and then this function run as a separate thread. So these are the API that we can use in the Windows for the trade pool. Okay, the next issue is about the trading issues that can be occurs when we talk about the trading in the operating system. So one of the issues is semantic of the fork function and the execution system call function. So those functions we already discussed in chapter 3. So okay, so these functions are used in order to create, separate, and duplicate the process. So the question now is, if one thread in a program call of the fork function, does the new process duplicate all the thread, or the new process become a single threaded? So that are the question and the issues in this what we call semantic of the fork function and the execution function system call. So some of the OS, some of the operating system, they have two version of the fork function. So they need to choose what version or not. What which one is the right version to be called. Okay, one of the version they use to duplicate all the thread, and another version duplicate only the thread that involve the fork system call function. So there's are the issues because we use the fork function in order to create, separate, and duplicate the process. So the issues here is if we have um if one thread of the program called the fork function, is it the new process will duplicate all the thread, or it just become a single threaded? The next part is about the signal handling. Okay, signal is used in the OS to notify a process that a particular event has occurred. Okay, we use the signal in order to do the notification. So signal may receive either synchronously or asynchronously. So it will depend on the source and the reason for the event being signal. And all signal, whether synchronous and asynchronous, will have the same pattern. Okay. The signal is generated the occurrence of a particular event, and then the signal is delivered to a process because it give a notification, and once delivered, the signal must be handled. So these are uh, about the signal synchronous and uh, asynchronous. So there are two possible handlers for the signal: a default single handler or a user defined signal handler. So handling in a single threaded program is straightforward. Now, what are the issues regarding the signaling or handling the signaling with the multiple thread? The signal are always delivered to a process because we have only one single threaded. Okay, in delivering the signal in multi-threaded program, okay, so the process may have many threaded, many threads. Okay, many threads. So the issue here where should be the signal delivered. Okay, when we compare this part into the single threaded is quiet. Uh, what we can say here is can be a problem because in single threaded it's just straightforward. So signal will deliver to a process. Now in a process we have multiple thread. So how we want to deliver the signal? Okay, so the process is more complicated compared to the signal single threaded signal. So in general, there are several options that exist. Deliver first, we can deliver the signal to the thread which the signal applied. Second, we can deliver the signal to every thread in a process. A process, it may have multiple thread if we talk about the multi-threading. The third option, we can deliver the signal to certain thread in a process. And the fourth option, we can assign a specific thread to receive all the signal for the process. So the method for delivering the signal depends on the type of signal generated, means how the signal is generated. Okay, the next point is about the thread cancellation and thread cancellation of target thread. So the issue here is about the asynchronous or deferred. So thread cancellation, it will involve the terminating of a thread before it has complete. Mean when you have a thread is running, so you click on button cancel. So we need to terminate that running thread. Okay. If multiple threads are concurrently searching through the database and one thread return the result, the remaining thread might be cancelled. Okay. Another situation might occur when the user press the button on the web browsers, okay, that stop the web page from loading any further. Okay, sometimes you want to surf and then before it's complete load, you just click on the cancel. So the web page load using the several thread, and each image is loaded in a separate thread. Okay, us when we stop the button on the browser, okay, all the threads loading the page are cancelled. Okay, that are the situation of the cancellation, the thread. So a thread that is to be cancelled is often referred to a target thread. So cancellation of the target thread may occur in two different scenarios. So the first scenario, asynchronous cancellation, and the second scenario is about the deferred cancellation. So this one is about the uh, asynchronous and deferred cancellation. So what is the asynchronous? Okay, in asynchronous, one thread immediately terminate the target thread. Okay, one thread immediately terminates the target thread. In the deferred, the target thread periodically check whether it should terminate or it's allowed the opportunity to terminate itself in an orderly fashion. So the difficulty with the cancellation occurs in situation where resources have been allocated to a cancelled thread, or where a thread is cancelled while in the midst of the updating data is sharing with the others. So usually, okay, the operating system will try to reclaim the system resources from a cancelled thread, but it will not reclaim all the resources. So the cancellation a thread asynchronously may not free unnecessary system-wide resources. So that are the issues that we can find in cancelling the thread with the multiple threading. Okay, you can find more regarding the deferred and the synchronous in the thread cancellation. Okay, the next part is about the thread local storage. So thread is belong to a process, okay, and then a process share the data of the process. So this data sharing will provide one of the benefit of the multi-threaded programming. Okay. However, in a certain situation, some circumstances, each thread might need its own copy of a certain data. So we have what we call as the thread local storage, or we or the short name is TLS, thread local storage. Okay, when we have this thread local storage, this TLS may confuse with the local variables inside the process. So local variables are visible only when a single function invoked. The TLS data are visible across the function of invocation. So TLS is similar to the static data. So the difference is that the TLS data unique to each thread that created. And most of the thread libraries, including the Windows NP thread, it provides some form of support for the thread local storage for the TLS. So the issues here is about the confusing between the TLS and the local variable. Okay, the next part is about the uh, scheduler activation. Scheduler activation. Okay. Um, what is scheduler activation? Okay, scheduler activation is the process or scheme of communication between the user thread library and the kernel. Okay. Between the user thread library and the kernel, so we call as the scheduler activation. So the kernel provide an application that we call as the LWPs, and then the application can do schedule the user thread on the uh, available processor, on the available visual processor. So the kernel must inform the application about certain event, and this what we call as the upcall. The upcall will handle the thread library, and it must run on the visual process. So these are the four issue interthreading or multi-threading issues. When we have the fork function and execution function system call, the signal handling, the thread cancellation, the thread local storage, and the scheduler activations. Uh, when we talk about the multi-threading, so there's are the issues that need to be checked in a good care regarding the performance and the efficiency of the trading. The next part is about the comparison between the synchronous and the asynchronous. This one is based on this signal handling. So in the synchronous transmission, okay, we send the data in the form of block or a frame. In asynchronous, we send the data 1 byte or a character at a time. So that's are the difference. And then synchronous transmission is fast transmission because we send a block of frame. In a synchronous transmission is quite slow compared to the synchronous transmission. And a synchronous transmission it costs more expensive. In a synchronous transmission is called economical compared to the synchronous. Time interval is constant at the synchronous transmission, while in a synchronous transmission, the time interval is random. So, example of synchronous transmission are the chat rooms, the video conferencings, and the telephone conversation. Example of the asynchronous transmission are letters, email, and form. So that's are the between the synchronous transmission and asynchronous transmission. Okay, this one is about the signal handling, as I mentioned before. So in the signal, this signal is being used in order for notification, and it used to process the signal using the signal handler. So signal handler is generated by a particular event and it delivered to a process. Okay, this one I already elaborate before. So every signal has the default handler that the kernel run when the handling signal. User define the signal handler can override the default and for single threaded signal delivered to the process. So the issues is between if we have the single threaded, it's just straightforward to send the signal. But if we talk about the multi-threading, so the process of notify quite confusing. So these are uh, the optional or the mechanism that we can use in order to deal with the signal handling for the multi-threaded. So it will deliver the signal to the thread which signal apply, okay, as I mentioned the previous video. So these are the mechanism that we can use in the multi-threaded. Okay, compared to the single-threaded, single thread is quite straightforward, but in the multi-threaded, we have several mechanism in order to send the signal. Okay, this part is about the thread cancellation, which we want to terminate the thread before it complete the process. So thread to be cancelled is target thread. We call as the target thread is refer to the thread that we want to cancel. And as I mentioned before, we have to approach synchronous cancellation and deferred cancellation. So these are the code, okay, for P thread to create a cancel thread. Okay, example here. So this one is to create the thread, and then this one is to cancel. Okay, the process is by invoking the thread cancellation request cancellation, but actual cancellation depends on the thread state. So the thread state is here. We have mode off, deferred, and asynchronous. So state disable, enable, and enable. So refer to this thread state. And then this one is start of the cancellation. So if the thread has cancellation disabled, cancellation remains pending until the thread is enabled. So then we can cancel it. Okay. The default type is a deferred, means that cancellation only occurs when the thread reach the cancellation point. Okay, using this function, pthread underscore task cancel. Okay, and in the Linux system, the thread cancellation is handled through the signal. Okay, the next part we go through the operating system example. Okay, we have Windows thread and Linux thread. Okay, in Windows thread, first we look at the Windows threads. Windows thread, in the window it implements in the window API. So the primary API for the Wins 98, Wins NT, and Wins 2000, Windows XP, and Windows 7. So the implementation is one-to-one mapping kernel. So the model is being used is 1-to-1. So each thread contains a thread ID, a register set that representing a set of the processor. This one refer to the thread based on the one-to-one model, and the separate user the kernel stack for when the thread run in the user mode or the kernel mode. So we can differentiate between the user mode and the kernel mode. This one is used the stack. Okay, private data storage used by the runtime libraries and dynamic link libraries, DLL file. Okay, the register set here, the stack and the private storage area known as the context of the thread itself. That's why when we talk about the thread, we mentioned that it's the basic of CPU utilization, and it's comprised the thread ID, the program counter, the set of register, and the stack. So this one is based on the Windows thread. Okay, the primary data structure of the thread include the thread executive thread block. So this thread include a pointer to process to which thread belong and to the K thread in the kernel space. Okay, thread is referred to the kernel thread block. Okay, the scheduling and the synchronization info, the kernel mode stack and pointer to the thread environment block in the kernel space. Okay, this one is referred to the K thread. And the thread environment block, we have the thread ID, the user mode stack, the thread local storage in the user space. Okay, this one at the kernel space, this one at the user space. So basically, it's like this one. We have the kernel space and we have the user space. So at the kernel space, we have the E thread and the K thread. At the user space, we have the TEB, thread environment block. So at the E thread, we have the thread start address, the pointer. So this pointer will point to this K thread. And at the K thread, it will point to the TEB. So these are the structure of the Windows thread. Okay, the next part is Linux thread. So Linux refer to them as tasks rather than thread. When we talk about Linux thread, Linux use the term task. Okay, in Windows it use the term thread. So thread creation is using the clone function system call. Okay, this clone function will allow the child task to share the address space of the parent task. In the previous chapter, we already talked about the parents, children, sibling. So hopefully you still can recall that part in order to imagine about the clone part here. So the flag control behavior, based on this one, we have the clone underscore fs. So fs refer to the file system. So if we have this flag, this flag rise up, so that means the file system information is shared. And then we have the clone the VM. Okay, VM here refer to the same memory space is shared. We shared the memory space. And when we have the clones Sahen, so this mean is about the signal handler Ashad. And we have the clone underscore files, that mean the set of open file is shared. So these are the flags under the Linux OS. And the structure, task underscore structure, this one point to the process data structure. Okay, so and okay, when we compare, we can compare between the Windows thread and the Linux thread. This one is the Windows thread, so we have the kernel space and we have the user space. This one is the structures. It use the clone part. Okay, so that's all for the chapter 4 regarding the thread. You should know that we have the multi-thread and we also have the single thread. So the ideas multi-threaded come from the single thread in order to utilize the CPU that we have in our computer system. Okay, so that's all. Thank you and Assalamualaikum.